Hi everyone, today's lesson is going to be on compositions of functions, day 2. So this is a continuation from yesterday's lesson. Before we can get into doing some examples, I'd like to review something first. You do not have to write this down if you do not want to. It's not on your worksheet, but just try to follow along. Okay, so if I gave you f of x equals 3x squared plus 4, and I asked you to find f of 2, you would all be telling me, well, in place of x, I see a 2. So in place of this x, I'm going to put another 2. And the way you want to set it up is 3, parentheses for the x, bring down the squared, plus 4. So the x would be 2. You'd plug this into the calculator, you'd get some number, and that would be your answer. Same thing for if I had asked you to find f of negative 3. So again, where x is, there's now a negative 3, so you're going to do the same thing. 3, negative 3 squared plus 4. Again, you'd put this whole thing into the calculator, you'd get an answer, and that would be that. But now, what if I didn't have the f of 2 and f of 3, or f of negative 3, and I ask you to find f of a? The concept is still the same. So wherever you see an x, you're going to put now an a. So it's still going to be 3 parentheses x squared plus 4. But now in place of this x, I'm going to put an a. So you know what? I'm actually going to finish this one for you. So we're going to do order of operations. So a squared would be a squared, and then we multiply it by 3. So 3a squared plus 4. That would be your final answer. Let's try another one. So if I have find f of x squared, so instead of an x, I'm going to put an x squared. So 3x squared, notice how I put the x squared instead of the x, and I have to square that. So notice, again, all the parentheses are just putting what these guys are here, and then I have the squareds come out, plus 4. So this would be, if we start here, x squared squared is x to the 4th times 3, would be 3x to the 4th plus 4. Now last but not least would be, if I want to find f of x plus 4, everywhere I see an x, I'm going to put an x plus 4. So 3x plus 4 squared plus 4. So now you would actually, to simplify this, you would have to realize that x plus 4 squared is x plus 4 times x plus 4. You would FOIL this out, get some answer, and then multiply it by the 3, and then add the 4. We're going to do examples like this in the classwork, but I want you to understand the concept of if I have f of x, an f of 2, f of negative 3, all that's changing is what's going inside these parentheses, and that's it. Okay, now I think we're ready to begin the lesson. So let's read along right up here on top where it says, the term compositions of functions means to combine functions in a manner where the output, what's another word for output? We could say the y values from one function becomes the input, or the x values, for the next function. Let's read that again. The term compositions of functions means to combine functions in a manner where the y values from one function become the x values for the next. Or in other words, the range, remember range again is y values, where the range of one function becomes the domain or the x values of the next. And remember that f of x and g of x are also called the y values. Now this is a lot of vocabulary. It's not necessary for you to understand so much the definition as it is to apply it to examples. So let's see if we can apply it to an example. So number 1, if f of x equals this and g of x equals this, find f of g of x. So I'm just going to write this the way that we like to. So f of, and I'm going to write the parentheses big, g of x. So now in examples that we did yesterday, there was a number here. It was like g of 2. We would find it in here and then plug that into here. But I'm not really doing that. I'm putting the entire g of x function into f. So instead of g of x, let's write what it's equal to. So g of x is equal to x minus 9. So let's cross this off and put x minus 9. So now we want to find f of x minus 9. So let's start with writing the f of x function. and we want to find f of x minus 9. So notice how I wrote it. Wherever there was an x, I put x minus 9. So wherever there's an x here, we're going to put this x minus 9. So 3 parentheses something minus 5. So notice 3x. The x goes here, so whatever's in place of this x goes there. So then all we have to do is distribute this. So 3x minus 27, and now bring down the minus 5. And the like terms are these. We can add those in the calculator. We'd get 3x minus 32. So your final answer for the problem, find f of g of x. So we could say f of g of x is equal to 3x minus 32. That's my final answer. Alright, these only get better with practice, so let's try another one. Example 2. If f of x equals x squared minus 5 and g of x equals 6x, find g of f of x. I'm just going to write this in a little bit more of an exaggerated way. So I want to find g of f of x. But what is f of x equal? X squared minus 5. So instead of this, I'm going to put x squared minus 5. So now I want to find g of x squared minus 5. So let's start with the g of x function. And I want to find g of x squared minus 5. So what does that mean? That means wherever I see an x, I'm going to put an x squared minus 5. So wherever I see this x, I'm going to put instead an x squared minus 5. So bring down the 6, and now instead of x, I'm going to put x squared minus 5. So we can distribute out the 6. So 6x squared minus 30. That would be my final answer. So again, the answer for g of f of x is 6x squared minus 30. Okay, let's try another one. Okay, number 3. If f and g are two functions defined by f of x is this and g of x is this, find g of f of x. So again, I'm going to exaggerate it. I want to find g of f of x. Notice how I just made it bigger. So f of x, if you look over here, is equal to 3x plus 5. So I want to find g of 3x plus 5. So let's start with the g of x function. X squared plus 1. And I want to find g of 3x plus 5. I got it from here, g of 3x plus 5. So again, it's x squared plus 1. So instead of x, I'm going to put 3x plus 5. So 3x plus 5 squared plus 1. So 3x plus 5 squared plus 1. Now remember, when we're squaring a binomial, we write it twice. So 3x plus 5 times 3x plus 5. We'll add this one later. Let's focus on multiplying this out. So why don't you pause the video, double distribute, and see if you get the same thing that I'd get. Okay, so you should have gotten 9x squared plus 15x plus 15x plus 25. Now I think we can bring down this 1 and combine like terms. So the 15x and the 15x we can add. So my answer would be 9x squared plus 30x. And then this 25 and 1 you can add and get 26. So again, to finalize this answer, g of f of x would be 9x squared plus 30x plus 26. Okay, number 4 is tricky because we've got some fractions. So again, the question is asking to find g of f of x. I'm going to rewrite it, exaggerating the parentheses, g of f of x. So they tell you that f of x equals this, 2 over x plus 3. So instead of f of x, I'm going to put what it's equal to, 2 over x plus 3. And we want to find that. So let's start with the g of x function. So g of x equals 1 over x. And I want to find g of 2 over x plus 3. So anytime I see an x, I'm going to plug in a 2 over x plus 3. So 1 over 2 over x plus 3. Now, unfortunately, we can't simplify this using the calculator. We're going to have to remember, when we divide fractions, you want to think keep, change, flip. This only works for dividing fractions. So do you agree that this numerator here of 1 is can be rewritten as 1 over 1? That's a fraction. So we're going to keep the 1. We're going to change the division to a multiplication. And then we're going to flip this last piece. So this last piece would be x plus 3 over 2. So again, we keep the 1, or 1 over 1. We change the division to a multiplication, and we flip this last one to bring it over here. And then you just multiply these two things. So we multiply tops with tops, bottoms with bottoms. So 1 times x plus 3 is just x plus 3. And the bottom, 1 times 2, is just 2. So this guy here is your final answer. So we can write this final answer as g of f of x is equal to x plus 3 over 2. Okay, why don't you try number 5 by yourself, and we'll go over number 5 in class. 5 is a review. Part A is a review of what we did the other day, and Part B is a review of what we did today. So just take a minute and try example number 5 on your own, and then we will go over it in class tomorrow.